Chapter 19 talks about the chi-squared test for qualitative data. Section 4 talks about how you can use a table to find the chi-squared distribution. So it says that you want to use Table D in Appendix C, and this will give you critical values from various chi-squared distributions for hypothesis tests that are at a 0.1, 0.05, 0.01, or 0.001 level of significance. For degrees of freedom, for a one-variable chi-squared test, the degrees of freedom equals C minus 1, where C is the total number of categories for the qualitative variable. If you always lose 1 degree of freedom when doing a one-variable test, this is just saying that it's always going to be C minus 1 instead of minus 2 or something like that. Section 5 talks about the chi-squared test. So first you want to assume that the null hypothesis is true. You want to view the observed chi-squared value with the context of its hypothesized distribution. If the observed chi-squared is smaller than the critical chi-squared value, the observed outcome is a common occurrence, and you will retain your null hypothesis. However, because of discrepancies, if there's a large difference between the observed and the critical value, if the observed is equal to or greater than the critical value, the observed outcome is a rare occurrence, and for this you would reject the null hypothesis. Next, the section talks about speculations about particular discrepancies. So all discrepancies contribute to the rejection of the null hypothesis. This means that you cannot just say that the largest discrepancy is what caused the null to be rejected, because there are many variables that go into place. To make the chi-squared test non-directional, all of the observed and expected frequencies should be squared. All the squared discrepancies have a cumulative positive effect on the observed x-squared value because the squaring takes away any negative signs. For a two-variable chi-squared test, you are now looking at the cross-classified observations in terms of two qualitative variables. You want to evaluate whether observed frequencies reflect the independence of two qualitative variables. In Section 6, it uses an example of a lost letter study. So in the book, it says that you are looking at the return rate of lost letters as a measure of social responsibilities in neighborhoods. Each letter is cross-classified on the basis of the type of the neighborhood where it is lost and whether it is returned or not. So those are the two different variables. Section 7 talks about statistical hypotheses. The null hypothesis in two-variable hypothesis is when the null hypothesis always refers to if there's a lack of relationship between the two qualitative variables under a population. So it's a test of independence. However, the alternative hypothesis always takes in the form of H1 and then the colon HO is false. So it's not making a claim or anything, you're just saying that the null is false.